Hello everyone. This project was prepared by RK20 Computer Engineering students. The title of this project is Frequency Response of a Robotic Position Control System. I am NURNAJWA FATINI binti Muhammad Nasrul, and now I will begin my presentation. This is the introduction of this project. Robotic is an interdisciplinary branch of engineering and science that includes mechanical engineering, electronics engineering, computer science, and others. Robotics deal with the design, construction, operation, and use of robots, as well as computer systems for their control, sensory feedback, and information processing. These technologies are used to develop machines that can substitute for humans and replicate human action. About 6 degrees of freedom refers to the freedom of movement of a rigid body in three-dimensional space. Specifically, the body is free to change position as forward or backward, up or down, left or right, translation in 3 perpendicular axes, combined with changes in orientation through rotation about 3 perpendicular axes, often termed yaw, pitch, and roll. Robots are described by their degrees of freedom. This number typically refers to the number of single-axis rotational joints in the arm, where a higher number indicates an increased flexibility in positioning a tool. The aim of this project is to determine the 6 axes or degrees of freedom by calculating the unity feedback position control system for a force sensing point. It is also to determine the gain and phase margin of the system to design a capacitor with desirable phase margin. The first objective of this project is to determine the gain and phase margin of the system. Next, to design a capacitor with phase margin of at least 35 degrees. And the last objective is to demonstrate the result using Scilab. For the methodology part, initially replace the S-domain of the transfer function to j omega. Then, split up the function into the constituent parts and identify constant, poles at origin, zeros at origin, real poles, real zeros, complex conjugate poles, and complex conjugate zeros. After that, start to plot the Bott diagram and consolidating the Bott diagram. Lastly, design a capacitor and determine which capacitor that would produce the phase margin with at least 35 degrees.
Hi everyone, my name is NURAYU MARDHATI binti Azhan, and I'm going to continue the presentation on result part of the project. We are required to design a capacitor, a unity feedback position control system for a force sensing joint has an open loop transfer function as shown below, with assumption k equal to 10. For the first step is replace the s with j omega, and then the transfer function is as shown below. Next, determine the magnitude plot and phase plot, and the equation is as shown below. This is a graph representation from Scilab which clearly shown phase and magnitude margin. With the details we gather, we are now trying to design the phase lead capacitor network.
Assalamualaikum, my name is IZZATI. I will continue about lead and lag capacitor. We are required to design a capacitor that the phase margin would be at least 35 degrees. First, we are designing lead capacitor. From the Bott plot, we get the phase margin 23.85 degrees and the gain crossover frequency is 5.91 radian per second. Using this information, we calculate the alpha and tau, that alpha is 2.5714 and tau is 0.1055. Using formula GC, 1 plus alpha tau S over 1 plus tau S, we got 1 plus 0.2713S over 1 plus 0.1055S. By using this detail, we generate code from Scilab to form the lead compositor. The compositor design cannot be lead network since the phase margin is only 27.73 degree, which is lower than 35 degree.
Hi, my name is Siti NURHALIZA binti Ramli. I'm going to talk about lag phase network. To design the lag phase network, we will find the new phase margin which is negative 140. The new gain crossover frequency that we get is 4.5283 radian per second. And the gain that we get is 3.679 decibel. The zero value that we get is 0.4528. Alpha value is 1.5276. The tau value that we get is 2.2085. The new transfer function that we get from all these is 1 plus 2.2085s over 1 plus 3.3737s. With all the value that we get, we change the coding in Scilab to get the phase margin. The phase margin that we get for the lag network is 37.97 degree, which is more than 35 degree. We are required to design a phase lag compensator so that the phase margin would be at least 35 degree. Because the phase margin of the phase lag compensation network that we obtain has a phase margin 37.97 degree. This is a few reference that we use for this project. That's all from us. Thank you.